All right. Shut up. We're going to have a quiz. I'll give you a hard homework assignment, and I won't do as much of the work for you. Okay. So last time, we were talking about variable types, things like that. We were also talking about how do we expand our variable environment to store more stuff than just a variable name. Well, now we need to expand our language so that our language can start to support some of those things. Okay? So, here's a new definition for a expression. All right, so give me an example of, so this is again reading a BNF. What is they're calling it a lit expression. What is a literal expression as you read this? What's that rule? Give me an example of something that meets that rule. Simon. Give me an example of something that meets this particular rule of an expression. Skippy. 7.
That conference from the test is
Yeah, Simon, you kind of missed it with Skippy. Dane was like in awe. Skippy gets his test back and he got the programming question right. Dane's like, how would you even do that? It's kind of like the movie Old School when Will Ferrell said, "So what just happened? I blacked out." And he did like the epic debate thing, some topic that he's way too stupid to understand. It's like, what just happened? I blacked out.
That's what kind of happened on that test.
What for you?
Yeah, I was blacked out.
You just went savant mode.
Yeah. Do that more often.
Yeah, but I mean, the funny thing, where the comedic timing was awesome, is you could hear it in Dane's voice. He was truly in awe of Skippy. I mean, he wasn't making a joke. He was literally shocked. Like, look, you're just as stupid at this as I am. How? That's what was in your mind, right? Yeah, I mean, it was clear as day. It was just... So, 7 would be an example of something that fits this one. Do you understand that? Because this expression is just a number. just a number. Okay, so when somebody talks about in Java or something and says this is just a literal is just a value. It's not a variable. It's the value a variable might hold. So literals would be our primitive type values, like ints and longs and chars. Those are literals. So things that you cannot change. I made a joke in the 250 class earlier today. For instance, you can't go and decide in Java, you can't do something like this, that A is actually a space. Because this is the assignment operator in Java, right? We assign whatever's on the left-hand side the value of what's on the right-hand side. We are not allowed to redefine what A is. Essentially changing the alphabet. We don't have that kind of power. All right, so literals are things that cannot be changed. They are built-in values. All right, so that's a literal. What's a var expression? Well, based on what I have here, what's a var expression? Again, we're reading BNFs, because our language is getting more complex now. We've been dealing with the simplistic language up to this point. What's an expression? Any of this crap, right? Now, what's a number? Do we pretty much know what a number is? Is it kind of self-explanatory? Okay, so a number would be the set of all numbers. The language containing the set of all numbers. If I asked you to write the BNF for number, what would you write? That would actually be a very good question. Take out a piece of paper. Oh, man, we're going to see how much some of you embarrass yourself. Create for me the BNF that represents the language of numbers.
Cannot compute. Tina, you better write that piece of paper.
I'm not asking you to write any scheme. I'm asking you to write a BNF. I will even leave this BNF up here, so you have a structure to copy off of. This is what a BNF looks like. Something like this. So I would like you to write the BNF, which, shut up! Write the BNF, which describes the language of numbers. You have 2 minutes.
Can you repeat that again, please?
Write the BNF that describes the language of numbers. Just like this is the BNF that describes a language of expressions. We'll make it simpler. A number is a single digit. So you don't have to, it doesn't have to represent numbers like 55. It just has to represent the numbers 0 through 9. So write me a BNF that describes the language of numbers. Again, given that this is a BNF that describes the language of expressions, as we're currently defining it, which is a little bit more bestest than we were defining it before. Most bestest, sorry, a little bit most bestest. Or better, most bestest.
Or asbestos.
About 30 seconds left. Is somebody raging?
Things.
All right, let's have them.
As I say,
I just scratched all of you.
I have a feeling this quiz is going to represent like the ultimate situation of people overcomplicating things. All right, Justin, garbage. 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 That's a good one. That's a good one. That's actually a pretty good one. That's garbage. That's a pretty good one. Yeah, it's pretty good. Garbage. 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 Ish. Garbage. Okay. A number is a 0. Or it's a 1.
Is it really
or it's a 2, or it's a 3, or it's a 4, or it's a 5, or it's a 6, or it's a 7, or it's an 8, or it's a 9.
Wouldn't that only be the base 10?
Huh?
Haha!
8 through after the numbers in base 16.
No, I specifically said it only had to work for 0 through 9. Didn't you guys hear me say that?
Yeah.
I said that, right? That wasn't just in my head?
You basically gave me.
I did give you the answer. So that's the language of numbers. So understand that just because we put the word language in front of something does not all of a sudden make it impossible, and it's like we're inventing a rocket to go into space to replace the shuttle.
Dude,
What's up?
who were you supposed to be?
I've actually gotten like random text messages from people, and like seriously.
Really?
Yeah.
Well, you know, Dr. Lippman's wearing his Halloween costume.
Everybody knows.
Everybody knows? Okay.
Beaker was supposed to wear his Halloween costume, but apparently messed up the hair. You don't even know who Beaker is, do you?
I know. I know. For sure.
Ryan.
Oh, really? Why is it?
Because of his Beaker shirt.
Oh.
He got the nickname Beaker a long time ago, and then he was going to come dressed as Beaker,
Thanks for not getting rid of the shirt.
but he messed that up.
Yeah. Okay. Oh well. Keep up the good work.
Plus, I don't think Beaker wears a Beaker shirt, by the way.
No, he wears a
No, he's
chocolate
got-
buns and honeydew shirt.
Well, he had a lab coat with him. I saw in the cafeteria. I was hiding under his table.
I didn't think it'd be nice to half-ass the whole costume, so I didn't wear it.
Half rear end.
That'd be like one.
All right, so this is the language of numbers. Okay, this is the language of numbers. Just because we put the word language in front of it does not all of a sudden make it hard. Okay? A couple people actually wrote something fairly interesting. So you could have written this a little bit more better by saying something like a number is a 0, or a number is a number plus 1, or a number is a number minus 1. Make sense? So you could do something like that. That allows you to cover a bigger base of what numbers are. Okay? But generally speaking, I think we all know what numbers are. Does that make sense? So keep in mind when we're dealing with B and Fs, at some point, this is like a chicken or the egg problem, at some point there has to be a base understanding of what we know. We don't necessarily need to define for us right now what a number is. If we were writing this language, though, we would need to define what a number is. So this specific language that we're defining here is a language of expressions where the only type of literal value that we support are numbers. We don't support chars. We don't support doubles. We support numbers where we're understanding numbers to be whole numbers. Okay? So again, not a very powerful language. More powerful than we had before, but not very powerful. So back to this question. What's a var expression? Is that a common knowledge question? Well, if I walked up to a random person on the street and said, give me an example of a number, do you think most people could do it? If I walked up to a random person on the street and asked them, give me an example of a var expression, do you think most people could do it? They're not going to know what you're talking about. So, what would be the BNF for a var expression? What's a var expression? I think that would be acceptable. Historically, if we're comparing it to our earlier language of expressions, it would be an identifier. It was our old rule number 1. Does that make sense? Why do you think we're going to call it a var expression here? Why do you think they've abstracted it and said, well, we're going to start calling this a var expression? What would your guess be in the context of what we were talking about the last class? Go ahead.
We're gonna add more type of BNF on the var expression.
var expressions are probably going to start becoming more complex. It's not just going to be a single variable name. It might have a type. It might have a value associated with it, that kind of stuff, right? So chances are var expressions are going to become more complex. So why don't we just go ahead and give ourselves the ability to think about it as a little bit more complex right now. When really, var expression right now is a synonym for an identifier. That makes sense? So we have a new rule 1 that didn't exist before. We have this thing called a literal expression. And our old rule 1 is now rule 2 that we've sort of kind of relabeled. Make sense? If expression, we've seen this before, right? Okay, this was, I think we had to add an if to one of our homework assignments. We had an if expression. So if expression, if some expression, then some expression, else some other expression. That's how a human being who understands what an if is would read it. But at this point, expressions are all the same. If we're writing a Java if statement, what is this first expression? Boolean expression. What's a Boolean expression? Any expression that boils down to a single value of true or false. Do we know how to represent trues and falses in our language yet? Here's my language right here. This whole thing. Do I know how to represent trues and falses in there? No, I don't define it. I know about numbers. Done. KK, thanks. That's it. That's all I know about is numbers. So at this point, I'm not able to distinguish between a Boolean expression and any other expression. Okay? So we're just saying an if expression is if followed by an expression followed by 2 additional expressions. Figure it out. Make sense? Now again, also understand that this language here deals with the representation of our language of expressions, not the execution of our language of expressions. Before long, we're going to start writing something called apply expression. And what apply expression will do is it will take in something that is an expression, something that meets this grammar. And it will actually execute it. It will look up variables in a variable environment. It will actually execute the Boolean expression and respond to it based on a true or a false. But at this point, we're not even dealing with the language, the functionality of language. We're dealing with the representation of the language. That make sense? Okay, so we have a if expression. Then we have a lambda expression with the one caveat that we have seen before, that it could take 0 or more parameters. We're not required to have any variables bound to a lambda, but we may have more than one variable bound if we'd like. Finally, we have a list of expressions. So this is a list of at least, I'm pretty sure that's a plus sign. Is there, you think it's a star? Okay, I'm fine with that. So this guy is, you think that would be easier to read, wouldn't it? All right. So this is a list containing at least one expression. And if you look at this and you notice Raider and Rands, so now we're looking for some context here. What do you think this type of expression is trying to simulate? We know what a lambda is simulating, right? That's kind of simulating a method. We know what an if is simulating. It's simulating an if statement. Var expression, number expressions, we understand those. But what's this last rule? What's that guy trying to simulate? And you kind of get a pretty good hint here at the bottom, like below that rule. Is this another quiz? A who? Okay. Why?
Well, wouldn't the reader be like?
I'm trying not to laugh, but go ahead.
I was just thinking because like the reader would be like this thing like, wow, this thing is true. I mean, Boolean expression do all these things.
You want a hint?
It's gonna be like I'm wrong.
No, you're definitely wrong.
Okay.
You think you're onto something there, Jake? All right. Go ahead.
It's an operation, like plus something has to be done.
Okay. So rater is an operator. So for example, you might have a list containing an operator that works on some operands. This would meet that that last rule criteria. Was there 5 rules? Whatever it is. That is, we have a list of an expression, followed by an expression, followed by an expression. This is a var expression. This is a number. This is a number. Our literal expression and a literal expression. We would expect, if we were to actually execute this, which we're not even doing yet, that this would give us a 3. Right? So this is an operator being applied to some operands. 0 or more parameters. An example here might be like, maybe you have a command in your language called exit. Exits the operator, and you don't need any operands for it to work. It just exits the program or something like that. That's why it would be a single expression. And you see by our definition here, this guy is a list containing at least one expression. An operator followed by 0 or more operands that it's built to operate on. Make sense? Okay. So that is our brand new, still simplistic language, but a little bit less simplistic than it used to be. We almost have a language where you might be able to accomplish something in it. Almost. So, let's start off with an easy 2-star. You don't want to start with a 3-star, do you? Now see, this should be an easy, actually, I'll tell you what. We'll only do the first part of this guy. We won't write the lexical address. I don't think lexical address is that important for us now, as long as we understand it. What's the lexical address? Remind me. Or we're writing it. So where it's located scope-wise. So lexical address relates to an individual variable expression, right? And as we replace every variable expression with a list containing the name of the variable and what its scope is, or free if it's not bound. Remember that? So lexical address kind of tells us where we can find this variable, where its most local scope is. Okay. So we want to write a data type for this guy and then parse and unparse it. What does it mean to parse this guy? Okay. What does it mean to analyze? I don't disagree with you, but take me down the path a little longer. So if you receive something that looks, that follows this language of expression, I write, what are we going to name this language? Just simplistic language, so maybe call it Simon. Okay, so we've just invented a brand new programming language called Simon. So if somebody were to give you some Simon source code, and I asked you to parse it, what are you going to do? So you said you're going to analyze it. What does it mean to analyze it? Simon source code is made up of a bunch of numbers and variable expressions and if statements and Lambda expressions and app expressions, right? So if I take his source code and I parse it, parsing is giving meaning to the syntax. So maybe what I want to do is I want to determine, take something that meets one of these criteria and turn it into something that looks like this. A lit expression, a var expression, an if expression, something like that. Okay, to kind of give us like almost a structured approach. All right. So we're going to do define parse Simon. This is going to hurt. This guy's going to be this guy's going to be a lambda expression that takes an expression as a parameter. Keep it down, Simon. We're parsing you. Our next more advanced language we'll call coleslaw. It's kind of like Android, like gingerbread and jelly bean.
It's like the appetizer.
We got Simon and coleslaw. Expression 3.0 beaker.
No Rain Man.
Release her final gold master release candidate is Rain Man.
25.
Okay, so we have a lambda. A lambda takes in a single parameter, an expression, and we're going to create our cond. I use a capital C there. What did I do? Cond. So one of our rules is we might be looking at a number. So if I'm looking at, well, if I'm looking at nothing, if I'm out of crap to parse, we've finished Simon. He's an empty husk. We'll boil down to the empty list. Otherwise, there's still something there. If we're looking at a number, we want to build a representation for that number. And what are we going to say? Maybe we call it a lit expression with our value. So why don't we boil down to list the word lit expression and then whatever our expression was, whatever that number was. So we're kind of giving meaning to it. We noticed that you are a literal expression. That make sense? So in some ways, we're writing the first part of our interpreter. What's the difference between a compiled language and an interpreted language? What does it mean to compile a program? I think I asked this last time, and everybody...
At the beginning, you first run it.
I got similar dumb answers last time. Did you watch the video?
That'd be why I said that.
Go ahead. Okay. Compilation means translating a high-level language into a low-level language. That specifically is what it means. Okay? What is an interpreted language? Remember way back several semesters ago when they had all those slides, there are two kinds of languages, three kinds of languages, blah, blah, blah. And one of them was there are two types of programming languages, compiled languages and interpreted languages. So a compiled language is a language where we take the high-level syntax and we translate it into the low-level equivalent, which has a one-to-one relationship with the CPU. Okay? And when we hear compiled language, we should have the red lights going off thinking about performance, high performance. Okay, now an interpreted language, how does an interpreted language work? And I'll give you a hint here. Scheme is an interpreted language. We've been using Scheme. I didn't know that. Dave's like, whoa. I never use Scheme.
Were we supposed to?
You could take that to the bank. So what's an interpreted language? Go ahead.
Converts into a low-level language as it's.
I don't necessarily have a huge problem with that definition,
but I would probably back off a little bit and not say necessarily a low-level language. It translates from one language to another. So think about an interpreter in real life. If I'm speaking English and Simon speaks Spanish, and we have an interpreter in the middle who I'm speaking English to, and they're interpreting it in the Spanish, English, Spanish are both high-level languages, the programming equivalent, right? So that interpreter is taking one high-level language and converting it into another high-level language. But that's not how the interpreter has to work, right? You might say, for instance, another kind of interpreter is people who do sign language. So they listen to somebody speaking English, for example, and they translate that into the language of sign language, which maybe you could argue is a less high-level language. So sign language is closer to assembly language than it is to a high-level language. Tends to be a little bit more granular, especially when there isn't like a certain sign for a word and you kind of spell it out in the individual letters and stuff. You know what I'm talking about? Okay, so kind of a rough example there, but I think interpreting doesn't necessarily mean high to low. I think it just means one language to another language, where the definition of the languages are unimportant. So we're writing an interpreter here that takes in a language that's written in Simon, and we're translating it into this other semantic language that we're inventing on the fly that kind of just tells us what kinds of expressions we're bumping into. So if we see a number, we're going to replace that number with a list containing the word lit expression and whatever the number was, to kind of remind us that we found an expression of a certain type. Make sense? So this is an interpreter. All right, so that's if we find a number. What's next? Next is we find a var expression. Well, var expression would be a symbol, right? So we'll replace all occurrences of a var expression with a list containing the word var expression and whatever the var expression was, the name of the variable. Okay, well, what's next? Well, we have an if expression. Now, our last three definitely involve lists, right? So we can assume that whoever wrote the Simon code at least gave us syntactically correct Simon code. So the next one says if EQV carve expression, what is it, if? This one an if? If it's an if, then what are we going to do? Let's see if some of you are really following what we're doing here. So if I'm looking at an if expression, go ahead, Beaker.
You can look back at this.
Yep. If I'm looking at an if expression, what do you want me to do?
We're going to the list. Apostrophe, or space apostrophe, then do the, I think it said list.
Probably, yeah, if expression, this guy.
List the remains of what it was. What was in the if statement. I think that's what, yeah. The remaining expressions in the if statement.
Okay, so how do you want me to write it?
Adder expression.
The carve the cutter?
Yeah.
That?
One more parentheses.
One more parentheses.
Actually, two more.
What?
We gotta close all these parentheses.
Well, that's all I want?
I think so.
I mean, the catter would just get me this guy. What about these other two?
I thought that gave the rest. Oh, it's just the footer.
Oh, you want me to have this as a list?
Right.
Okay. So you don't want me to say the catter. You want me to get the cooter of our expression as one big list. So we have a list containing whose first element is the word if expression and whose second element is the list of those three expressions. Right?
Yeah.
Okay. Yep. Tell me why this is wrong.
Because Beaker said it.
No, hold on. This is good. The way Beaker is thinking about this is the way I expected some of you to think about this. In fact, is the way I expect most of you are thinking about this. This is again going to be part of that understanding of what's actually going on. Go ahead, Beaker.
Doesn't have to be just a list. Well, no. Oh, do we have to call?
What is this guy?
It's an expression.
He's an expression. What do we do to expressions?
We have to go parse it.
We parse them. Right? We can't just put it onto a list. We're ultimately going to do what you're saying here, but we got to go parse those expressions. I have 3 expressions there. Who knows how complex those are? There might be 6,000 lines of Simon code in each of those that we're just wrapping into this list that just says, here, I ain't touching this. So we need to do something to those expressions. So we'll create a list where the first element is an if expression. And then you want to create a list of the other 3 expressions, right? So first element is a if expression. Then the second element will be a list containing what? Parse Simon of catter expr. And let me kick this down a line here just so we can. Okay, parse Simon of catter expression. And what is that going to get us? That's going to get us this piece right here. The car of the cooter. So the cooter of this if statement would be the list containing expression, expression, expression. The car of that will give us just this first expression. Make sense? So we're going to create a list of whatever is returned by parse Simon on that first expression, and then whatever is returned by parse Simon on that second expression, which is the car of the cooter. And then whatever is returned by parse Simon for the third expression, which is the car of the cooter.
I'll never get over how stupid
Does that make sense? Okay. Now, is everybody following what we're doing here? We're just interpreting. We are translating Simon syntax into this new invented syntax where we have words like lit expression and var expression and if expression. Might be a huge waste of time, but maybe we can use this var, lit, stuff like that later to do something else special. Something like that. I think it'll make sense to you once this is kind of the gateway drug to do something more powerful. Okay? So that's what we do if we see an if. Well, keep going down the list. What about a lambda? The next difficult one. Think you got it? Okay. So if I'm looking at a lambda, I want to create a lambda expression, right? Okay.
the list. Start off the same way you did there, so list and lambda expression.
Okay.
And you go back to
Yep. Now we want another list, similar to what we had up here. Okay, so we're going to create a second list. So its contents are going to be a list containing what? The IDs and the body.
When you see the little phrase IDs, what does that say? What are you expecting that to look like?
A list of var expressions.
Fair enough. List of var expressions, but the reality is it's a list of identifiers. Notice it calls them identifiers, not var expressions here. See that? It calls these guys identifiers. It doesn't call them var expressions, which kind of leads us to believe that as var expressions evolve, they're going to become more than just a symbol, just an identifier. Make sense? So that's why they're already starting to slide them away from each other, even though right now they're the same thing. Okay? So this guy is an identifier. And you're thinking that when it says IDs, you're expecting it to be a list of identifiers.
Yeah.
Correct? So like ABC in a list.
Mhm.
Okay? So how would I get my list of identifiers? Here's my lambda again. This is what it looks like. After lambda, what's the next part of this expression? Identifier inside what? A list. We kind of have a list of identifiers, don't we? Isn't this exactly what we want? A list of identifiers?
Yeah, so just keep that.
So how do I get this? What's this part? This is my whole list.
Oh, so it's going to be the car of the.
Car of the cooter. So the cooter gets me the list containing this list and the expression. So the car of the cooter gets me the list of identifiers. So the list containing the catter of my expression. And then, what's the last part?
Parse, sign, car of the critter.
Good. Parse Simon, car of the cooter expression. That's what we do if we see a lambda. Make sense? Okay. Make sure that we are okay. That's fine. All right, what's our last one? Last one is this thing called an app expression. So can I just put this inside the else? Otherwise, I must be looking at one of these dudes. So else, I'm looking at an app expression. If I'm looking at an app expression, I want to return a list containing app exp, followed by what? When you see Raider and you see rands, what do you think Raider and rands are? What's Raider? What's the operator? Is it one thing or is it many things? It's one thing. It's a single operator. It's an expression, right? All right. So we want to have a list whose first element, we'll stay consistent with what we did up there. A list whose first element is what? Come back here. What's the first element? Read the B and F. Okay, it's an expression. What do I do with expressions? Parse Simon on the expression. And how do I get to that expression? Car. So I want this to be a list of parse Simon car expr. That's the first part of it. All right, $10,000 question. What's the rest of this? How many rands are there? What's the minimum number of rands? 0. Minimum number of rands is 0. What's the maximum number of rands? Something a lot bigger than 0. Right? We could just say infinity. So, how might... But now, all the rands are what? What kind of animal are the rands? Each rand is a what? Expression. And what do I do with expressions? Call parsimon. How many times do I need to call parsimon? 0 or more times. How do I do that? Map. I'm going to map parsimon. Map parsimon across the cooter of my expression. The cooter of my expression is a list containing 0 or more expressions. That make sense? But we're not quite exactly where we want to be yet. Almost, very close. Well, we possibly are where we want to be. Rands, do we want to represent these guys as a list of expressions? A list of operands? Is that what you want it to be? A list? Okay. Then I think we're good then. So, if we see an app expression, we're going to create a list whose first element is the word app expression, whose second element is a list, whose first element is the parsimon result of our operator, of the first expression, and whose second element is a list where we have taken parsimon and applied it to every single element of the cooter of our expression. All the operands. So the cooter of EXPR is a list of operands, 0 or more operands, each of them stored as an expression. What are we going to do? We are going to map the parsimon procedure onto every one of those expressions, which should boil down to a list. Go ahead.
So if it's 0 and we parse it, it'll go back up to the null and just give an empty string.
If it's
If there aren't any things in that expression.
it won't even get to that. It just won't. It'll never call it.
Okay.
If it's an empty list in there, it's applying it to 0 elements. All right. There you go, Dane. Look at all those parentheses.
Makes me happy.
Okay, so that's parsimon. Now let's test it. Parsimon, and we need to call it on. Well, here, let's actually define a couple of expressions. Define expression 1 to be, we want to give something that's a parsimon expression. Let's do a simple one. Now let's give a one that meets our second criteria. What's our third guy? An if expression. If A, then 5, else 7. So let's stop right now and let's go and call parsimon on some of these. Parsimon in E1 should give me what? Lit exp5. Lit exp5. That's what it is. This entire expression, which is a legal Simon expression, is a literal expression
that has the value 5. What if I pass it E2? What's that guy? He's a var expression with A. Var expression, A. What if I pass it E3? Now we have an if statement. If A, so what should the result of calling parse Simon on E3 be? It should not be an error. Yep, it should not be an error. What should the result be? I'm not asking you what the output of your stupid program was. I'm asking you what the output of the program should be. Use your brains, not what your messed up scheme program says. Okay, so it should be a list. Are you copying code or are you trying to figure this out?
I'm trying to figure this out.
Okay. That's as far up as you need then right now. So Beaker, you expected it to be a if expr, or if exp,
Yeah.
right? And following that, you should have a list. So another list. What should the first element of that list be?
Var
Var
expression.
exp a. What should the second element of that list be? Lit exp 5, then lit exp 7. That's what we expect the result to be. That make sense? That proves that we've parsed through this. We found an if expression. The if expression had 3 parts. It had a var expression, it had a lit expression, and it had another lit expression.
My crop dusting smoke you out.
Okay, so we see we have a list containing an if expression, followed by a list where the first element of that list is a list that is, ooh, interesting actually, an app expression. Should it be an app expression?
Because it was a list of expressions.
Say this again.
Yeah, with mine.
Okay, I got it. So we have an if expression. Oh, here, let me go like this. So we have a list that's an if expression, followed by a list where the first element is a list of var expression A. Second element is a list lit expression 5. Third element is a list lit expression 7. Okay, and that's what we're looking for. Okay. Well, let's keep going. Let's do define E4. Define E4, we want it to be one of our lambda expressions. So why don't we do this? Why don't we say this is a lambda expression, ABC, followed by an if expression. So we'll take E3 from above. So now we have a lambda expression that has a parameter list ABC, and whose body is an if expression, which has a var expression and two literal expressions. That's E4. So now we've combined our fourth rule with our third rule, with our second rule and our first rule. So this expression uses all the stuff up to this point, doesn't it? We have a lambda expression. We have a var expression. We have two literal expressions. We have an if expression. So here we go. We got a lambda expression. Lambda expression has a list of parameters, A, B, and C. That's our identifiers. Then we have a list if expression, which has a list var expression, lit expression, lit expression. So this describes the bone structure of that expression E4. Make sense? Okay. Define E5. This guy is a list of expressions where the first expression is an operator and the last expression is, well, followed by 0 or more operands. So if I say E5, A, like that, what should the output be? What's this expression? What kind of expression is that? It's an app expression whose first element is a what? Which is a var expression followed by nothing else. We have an app expression containing a var expression and nothing else. This is what was returned by map. So to answer your question, I don't remember who asked it. Maybe the speaker. Did you ask about what happens if we call map on an empty list? You get empty. Similarly, we can say this on this. So we're going to apply A, the var expression A, to this guy and this guy. That should be pretty scary. So our operator is the var expression A. The first operand is a lambda expression containing this list of parameters followed by an if expression that contains a var expression and two literal expressions. That's our first operator, or our first operand. Second operand is an if expression containing a var expression, which then it has a literal expression and another literal expression. So this should be a nice wall of output. Oh, look, that's Dane's kind of output right there. Like, man, look at all those parentheses. Boom. All right, does that make sense? So now we see the real output of our map. So we're looking at a map expression, or I'm sorry, an app expression, where the operator is a var expression A, and our list of operands are a lambda expression containing ABC as the parameter list, containing an if expression, containing a var expression, lit expression, and a lit expression as its body. And our second operand is an if expression containing a var expression as the Boolean expression part, a lit expression as the true statement, and a lit expression as the false statement.
So this was the output of map being applied to those two expressions, the list of two expressions. Does that make sense? Okay, so now as we kept feeding it bigger and bigger expressions, more complex expressions, which by Java standards, let me drive this back down. Oops, sorry. These are pretty simplistic expressions in terms of a whole Java program, right? But for us, we were trying to make them kind of scary by putting lambdas and ifs inside of each other and that kind of stuff. Okay? But these are fairly simplistic things, yet our output is fairly verbose. It's like, okay, we're using we wrote this interpreter, and the interpreter is making our output bigger than our input. What's the point? What do you think we're going to use an interpreter like this for?
Probably some torturous assignment.
Well, besides that. Now remember, I called this a parser. So now we got to go back and decide what does it mean for something to be a parser. Say this again? Give it meaning. Okay. Well, give what meaning? In this case, it would be the expression. So, if we go back over here, we just did the first part of this two-star question. What's the second part? Second part is unparse. Reverse that. Take this output, something that looks like this, and turn it into this. Make sense? So I'm going to give you all the code we did so far. How to turn this into this structure. And then what you're to do is to write an unparse. Takes this structure and turns it back into this. Make sense? Any questions about what I'm asking you to do? What's up? You don't need a BNF of the unparsing. Oh, I see what you're saying. You want. Well, no, you won't need a BNF of it. You have examples down here. Here's your examples of unparsed things. So if you run parse Simon on E5, and then you ran unparse Simon on the output of parse Simon, you should get back to E5. Unparse Simon of parse Simon E5 should be E5. They reverse each other. That make sense? All right. Unsimon. Well, I think we wrote parse Simon already, right? So now we're calling unparse Simon. Restuff Simon. Say this again.
We need to talk to HR. I'm going to be stuffing it.
If I'm going to be stuffing a fellow student, do I need to get pre-approval for this type of thing? All right. Any questions about what I'm asking you to do for next class?
I think they've given you an assignment to define stuff.
All right. I'll see everybody on Tuesday.